Welcome to Small Code Learns.
In this video, we will about constructor and its type with real-time examples. First, what is constructor? A constructor is a special method in a class or struct used to initialize objects. Constructor must have the same name as the class and does not have a return type. Types of constructors. 1. Default constructor. 2. Parameterized constructor. 3. Static constructor. 4. Copy constructor. 5. Private constructor. 6. Constructor chaining. First we will see about default constructor. A default constructor is a constructor with no parameters. It's used to create an object with default initial values. If you do not define any constructor, C# will automatically create a public default constructor for you. There is two different type of default constructor. 1. Compiler generated default constructor. 2. Explicit default constructor. First we'll see compiler generated default constructor. Created automatically by the C# compiler. Only created if no constructor is explicitly defined. It does nothing except allow object instantiation. Let's see the example. I am creating car class, declare two instance variables, bool is electric and int model, they are fields of the class, automatically initialized to their default values when an object is created. When you create instance for car class like, car equals new car. It allocates memory for the car object, initializes fields, is electric equals false, model equals 0, automatically and calls the default constructor. Inside the constructor, I use those variables, and they show their default values. It's called compiler generated default constructor. Now, let's see what an explicit default constructor is. We use an explicit default constructor when we want to define it ourselves. It takes no parameters and allows us to add custom initialization logic. Let's continue with the same example. Here, I'm just initializing values like is electric equals true and model equals 2025 inside the constructor. Now, when we run this program, it will print only the values we explicitly initialized in the constructor. So, for a compiler-generated default constructor, the compiler automatically initializes the variables with their default values when the constructor is called. In contrast, for an explicit default constructor, the user is responsible for initializing the variables manually within the constructor. Now we move to parameterized constructor. A parameterized constructor is a constructor that takes one or more arguments. It allows you to pass values at the time of object creation, so you can initialize the object with custom values. Let's start with a real-time example. A product inventory system. Imagine a simple inventory system where we want to track each product's name and price. Let's create a class named product, which includes two fields, name and price. A parameterized constructor that accepts values for these two fields. We'll create an instance of the product class and pass the name and price directly to the constructor. Inside the constructor, we'll print the product name and price to the console. We'll execute the program and observe the output. Now it prints exactly what we passed via the parameterized constructor. I hope you now clearly understand the concept of a parameterized constructor. It allows values to be passed during object creation and used inside the class immediately. Now let's move to static constructor. A class contains a static constructor. It will be called automatically by the CLR before any static or instance members of that class are accessed. Static constructors are used to initialize static data or perform type-level tasks. You cannot control when they are called. CLR handles that. It's useful in cases where you want to do a one-time setup for a class. Let's example in this program. I've created a static constructor for this class and added a print statement. Static constructor executed. I also declared a static variable add and initialized it with the value static constructor stop. In the main method, I'm printing the add variable. Now, let's run the program. Even though I haven't created an instance of the class, the static constructor still executes first. After that, the program continues to the main method. I hope you now clearly understand how a static constructor works and when it is executed. Now let's move to copy constructor. A copy constructor is a special constructor used to create a new object by copying the values from an existing object of the same class. It means in technically create a new object with the same data but different reference. You must define it manually in C#. We'll see how it works line by line with a real-world example. Let's dive in. We start by defining a class called product. Inside this class, we declare two fields, name and price, to represent a product's details. Next, we create a parameterized constructor. This constructor takes two inputs, the name and the price, and assigns them to the fields. This is used to create a product with custom values. Comes the heart of today's lesson, the copy constructor. This constructor takes another product object as input. Notice the parameter is of the same type as the class. Inside it, we copy the values from the existing object into the new one. This way, we're cloning the object, not just referencing it. We define a simple method called display to print out the product's name and price. This helps us visually confirm that the copied values are correct. Inside the main method, we create a new product P1 using the parameterized constructor and pass laptop and 55,000 as the values. Now we create another product P2, but this time using the copy constructor. We pass P1 as the argument, which copies all its data into P2. Finally, we display both products. The original and the copy show the same values, but remember, these are two different objects with the same data. Always remember, in C# you must define the copy constructor manually. It's not built in like in C++. But it gives you full control over how you clone your objects, especially when dealing with deep copies or reference types. Now let's move to private constructor. A private constructor is a constructor that is only accessible within the class itself. It is not accessible from outside, meaning you cannot create an instance of the class using the new keyword from another class. For example, singleton design pattern. This is where your program begins execution. We're calling logger.getInstance, instead of using new logger, because the constructor is private. Since this is the first time getInstance is called, _instance is null. So we enter the if block. Even though this constructor is private, we can call it from within the class. That's how singleton works. This message confirms the instance is being created for the first time. Now _instance holds the created object, and we return it. Next time, the same instance will be reused. We now call log method on logger1. Since the logger is initialized, it just prints the message. We call getInstance again. Let's step into it and see what happens. This time, _instance is not null, the object was already created earlier. So we skip object creation and return the existing one. Logger2 is using the same instance as logger1. So we're following the singleton design correctly. So what did we learn today? A private constructor blocks external object creation. It's essential when implementing patterns like singleton, where only one instance of a class should exist. Instead of new, we use a public static method to control object creation. Now let's move to constructor chaining. Constructor chaining in C# is a powerful concept that allows one constructor to call another constructor within the same class or from a base class. It's mainly used to reuse constructor logic, avoid code duplication, and ensure consistent initialization. It will happen two different types. 1. This, rightward arrow calls another constructor in the same class. 2. Base, rightward arrow calls a constructor in the base, parent, class. First we will see about constructor calls another constructor in the same class. I am going to create a car class with two fields, brand and year. Now, we'll define two constructors. I'm going to call Parameterized from default constructor. But notice something special here, we're using this default brand 2023 dot. That means, instead of writing logic here, we are calling another constructor in the same class, the parameterized one. This is called constructor chaining. Now we're creating an object using new car. Since we're using the default constructor, what happens? So the output clearly shows that the parameterized constructor runs first, followed by the default one. Now we will move to, Constructor calls another constructor in the base, parent, class. Here we have a base class called vehicle, and it has a constructor that accepts a type string. When this constructor is called, it prints a message including the type of vehicle. Next, we have a derived class bike that inherits from vehicle. Notice the constructor, it calls base, two-wheeler. This means before running the bike constructor, it will first call the vehicle constructor and pass two-wheeler as the argument. In the main method, we're creating an instance of the bike class. Let's walk through what happens during execution. Instead of writing logic here, we are calling another constructor in the different class, the parameterized one. Hope you now clearly understand how constructor chaining works in C#. If you liked this video, please hit like, subscribe, and leave a comment on what you want to learn next. Thanks for watching Small Code Learns.